The recent moderate magnitude earthquake that 5 million people felt in Australia has brought a good deal of attention to the fact that seismic hazards do exist in the country. So, I thought it would be appreciated that I show you all what exactly an actual historical worst-case scenario looks like, not in terms of the overall level of destruction an individual earthquake caused, but rather through showing the strongest earthquake recorded on mainland Australia in modern times. First, let's compare the maximum intensity of shaking that the recent 5.6 earthquake caused northwest of Brisbane with the same magnitude earthquake southwest of Newcastle that caused billions of dollars in damage and 13 fatalities in 1989. And now I am going to compare that latter earthquake with a simulation of the most intense shaking Australia's largest historical earthquake caused. If you are wondering what is the exact difference between these two simulations, the answer is the one on the right shows ground motion 3.5 times stronger than the one on the left. The one on the right represents a magnitude 6.6 earthquake that struck a fairly remote portion of the sparsely populated Northern Territory late in the night of January 22, 1988. And that earthquake wasn't alone. It was preceded by 2 other magnitude 6 earthquakes on the same day, striking within a week's time of 4 magnitude 5 quakes and 10 magnitude 4 quakes. This all occurred across what is today known as the 1988 Tennant Creek earthquakes, which in essence represent a single earthquake sequence. There thankfully were no structures that experienced anything stronger than MMI 6.5 shaking, which caused some minor damage. Yet, while no inhabited structures experienced MMI 9 shaking, which has this scary definition meaning you don't want to experience it, there is something that did. A series of gas pipelines. As a result, a series of 14-inch diameter steel pipes were severely bent as seen in this photograph. Some damage also occurred to the Tennant Creek Hospital and a local home. This comprises all of the damage caused by all 3 of the magnitude 6 quakes on that day, of which the largest was the third to strike. The first quake, a magnitude 6.2, struck at 10:06 a.m., with a magnitude 6.3 following at 1:57 p.m., and the magnitude 6.6 at 10:05 p.m. All of these occurred in close proximity to each other and caused the faults they were associated with to rupture on the ground, creating visible scarps more than 30 kilometers or 18 miles in length. Here are a few images of those fault scarps. This caused the ground to move by up to 3.5 meters or 11.5 feet across portions of both the Kanayunku and Lake Surprise faults. The earthquakes which struck all were of the same type, associated with thrust faults related to regional compression. This compression is caused by both the uneven motion of the Indo-Australian tectonic plate, although it is mainly caused by the strain that originates from the tectonic plate boundaries to the far north. These then build up over time until a part of the Earth's crust moves to accommodate this strain best, with that generally being a reverse fault that generates an earthquake. Even in 2025, aftershocks from the aforementioned Tennant Creek earthquake sequence are still occurring, albeit at a far reduced rate when compared to the month following the main shocks in 1988, with the last such quake being a magnitude 2.7 that struck on June 7, 2025. The good news is that what occurred in 1988 was a truly rare event, at least on the fault lines in question. An earthquake of a similar magnitude was discovered to have not occurred on the same fault lines for more than 50,000 years preceding the quakes in question, suggesting a very low rate of events. However, while this is not an official figure, I drew multiple regional fault lines I could spot, and assuming that all of these are still active, determined that in a worst-case scenario, up to a magnitude 6.8 quake could theoretically strike the same region in the future. So, aren't we all glad that these 1988 earthquakes struck away from densely populated cities? As a final note, I would like to thank my new patron Mike White for supporting my work.